Hello class, and welcome back for part 2 of 9-2. And we are going to be working on area of a regular polygon. So this should be really new for most of you. And go ahead and pause and write down this title bar up here. You should be on the left-hand side of your comp book. And you should have a second little page of notes that we're going to talk about. So go ahead and pause and get this taken down. All right, and welcome back. I do want to talk about some vocabulary words that are going to be important for us. First one being, where's the center of my polygon? And then the other one is the apothem. So apothem is going to need to be put in your vocabulary section of your comp book. All right, so the center is going to be equidistant from all my vertices. So think of this like the radii of a polygon. All of these are going to be congruent to each other. Now you'll notice we even have some triangles created inside of our polygon. The apothem is the distance from the center to a side, and this is going to be a perpendicular line segment. It's going to go from the center, it's going to be perpendicular to the side. So now notice I have a little right triangle inside my polygon, and we said geometry is all about finding the right triangles. Also, our formula is 1/2 little a times big P. The little a stands for our apothem, and the big P stands for perimeter of the polygon. So we will have to define some perimeters, and all of this is going to help us find our area. All right, so let's get started with our booklet. First thing we're going to have to do is find some central angles. Central angles are going to be helpful in finding the area. So I want to practice finding some central angles. First one I'm going to do is a pentagon. This is in a regular polygon, which if you remember your vocabulary, regular polygons are equilateral and equiangular. And central is going to be based off the center. So here's my generic picture. And if I add in all of their radii, I'm going to be looking for this angle right here from this triangle that's formed. If I look to the whole polygon, this is going to be based off if I went all the way around the inside. And we know that if I go all the way around, that's going to be 360 degrees. So hopefully you've already drawn the conclusion that to find one of those angles, all I have to do is divide by the number of sides, because that's how many triangles I have in there. So 360 divided by 5 is going to give me 72 degrees. And that's it. That's simple. As long as it's a regular polygon, this is going to work out for us. So now I want you to practice. If you open it up, you'll have to find a hexagon. Remember, it's 6 sides. You'll need to find an octagon, which I spelled incorrectly. And you know that is 8 sides. And then the last one I want you to practice is a decagon. And if you don't remember, a decagon is a 10-sided figure. All right. From here, we're going to practice finding the area of a regular pentagon. And sometimes we have the apothem, sometimes we have the side. So I'm going to do one with the apothem, one with the side. Then I'm going to ask you to do one with the apothem, and then one with even something else, kind of like having the radius. All right, so here we go. Regular pentagon we know is 5 sides. I am going to write my formula. So 1/2 a times big P. I know my a, but my problem's going to happen when I don't know the side length. So give myself a little sketch to get started. Put in my apothem, and here it is. I don't know my side length, so that's going to be a problem. So we need to use that idea of the central angle and the triangle that was formed. That way we can find the side length. So now those trig functions are going to come back and get you. Remember, if I have an angle and I have a side, then I can find the other side. So if you don't remember, jot yourself a little note about SOHCAHTOA. And here's what we're going to do. So first I need to know my central angle. We already found it on the first page. It was 72 degrees. And I'm only going to look to the right triangle. Remember, trig functions only work with right triangles. So here's my right triangle. I only need half of the central angle. So half of 72 is 36 degrees. And I'm going to redraw this triangle over here just a little bit bigger so I can see what's going on. Here's my apothem of 4. Here's half of the side that I'm finding. And then here's my 36 degrees. So ask yourself, what do I have and what do I want? I have the adjacent. I want the opposite. So tangent's going to be helpful. So tangent of 36 degrees equals the opposite over the adjacent. Now I can solve my proportion, and x equals 4 times tangent of 36 degrees. Throw it in my calculator. Make sure you are in degree mode. So mine's in degree mode. 4 times tangent of 36. And I will have to round. I'm going to round this to 2.91. So 2.91 is my value of x. Now remember, this is just part of the side. So to get the whole side, I will have to take that 2.91 times 2. And I get a side length of 5.82. Now I'm ready to solve. So I know it takes a little bit of work. If you run out of room, write on your comp book and just make sure you're marking everything to stay together. So now I'm ready for my formula. 1/2. My apothem was 4. My perimeter is going to be 5 times the 5.82, which is 29.1. And I can just throw this in the calculator and get my area. So I'm going to want you to do that and come to class already with an answer. I've done everything but the calculator. All right. So now I'm going to do the next one with you. This is finding the area of a regular polygon. And this time, instead of having the apothem, I actually have a side length. All right. So this regular polygon happens to be a nonagon. Remember, nonagon means 9 sides. And I don't really draw nonagons very well, so I'm only going to draw that interior or that inner triangle, where this is my apothem right here. This is kind of the other half. And this whole piece here is 6. That's my side. So I'm only going to be working with 3. And then I need to know this angle measurement. So if I find the central angle, so 360 divided by 9. And then remember, I'm only working with half of that inner triangle, so this is going to be 20 degrees. Now I'm ready to go. What do I have? What do I want? Again, tangent's going to be needed. So tangent of 20 degrees equals opposite over adjacent. And hopefully you remember how to solve these. They're a little bit different. I have to cross multiply. X times 20 degrees equals 3. Now remember, tangent of 20 degrees stays together. And what I'm putting in my calculator is 3 divided by tangent of 20 degrees. Here you go. Hit enter. I will round, so I'm going to say 8.24. Look back to my picture. This is my apothem, so I don't have to multiply it by 2 this time. And now I'm ready for my formula. So area equals 1/2 times the apothem times my perimeter. Well, I had a side length of 6. I have 9 sides. So 6 times 9 is 54. And you should be ready to come to class with an answer. All right, on your own, I want you to try this one. So this would be problem number 6. Number 7, you have the apothem, so it's going to match problem number 5 on this side. And then on the back, you have something a little different. So here's your challenge problem. This time you have 2 centimeters, and it's not the apothem, and it's not the side length. So it's kind of like having the hypotenuse of that inner triangle. So I can't wait to see what you come up with. All right, I hope you enjoyed your notes and your video and everything works out for you, and I look forward to seeing you tomorrow.